Hello team, welcome back to TechFit channel. Today we will be discussing how to delete nth node from the end. So the requirement is here that an interviewer asks to check your logic how you implement, how you delete the nth node from the end. So what he means that suppose you have multiple nodes, okay, and okay, so then all are linked, right? So one node will have address of first node will have address of second will have address of third, and so on. At the last it will terminate with the null, just for uh, your revision. So now the requirement is, suppose user wants the requirement is user wants to delete the second node from the end. So second node, this one is the first node and this one is the second node, right? So how to delete the second node? You don't know, right? As per now, means there will be one idea that traverse till end, and then keep keep the counting, and then keep the counting, and then keep always save the previous, and it will not work out, right? Because there will can be the n number of nodes. So you need to implement some logic that uh, how to delete the nth node from the second. So let's take an example, the second node here. So what I am going to do, that I will take the two pointer s and f. F is the first pointer, s is the slow pointer. What I will do, that I will initialize both to the head, okay, head and this, and then I will do, I will move the first pointer. Suppose nth node from the second, right? So the logic is I will move the first pointer to the second node from the start only. So it will point to the second node from start. Okay, so I will make it second. So it will be basically s plus n, s plus n it will be. So start will be, a slow pointer will be here only at the start, and it will point to second. So now after that what we will do, while f will not point to the null, we can move each by one. We'll hop each pointer by one. So for example, now we will start traversing f, while f dot next not equal to null, we'll hop both. So now so I, in the first traversal, f as f is equal to 2, now f will become 3, and s will become, s point to next, so s will become 2, right? Again this will move to 4. I will check f point to next. What will be next here? It will be 4 here, right? So 4. So now it will move to 4. It will go to 4, means it's not equal to null, is there is 4, so it will go to 4, and here it will go to, s will go to 3, and this will be 4. Hope you are understanding me what I am denoting 1, this is 1, this is 2, this is 3, and this is 4. Okay, and this is null, and this is 4, this is 3, and this is 2. So now I will check, and now f is at 4, s is at 3 here. Now I will check f dot next is equal to null or not, then we will again traversal. So now 4 dot next is null, so we will not traverse. Now s is at 3. So what we will do now, we need to delete this, right? So we need to delete this. So what we will do, so here it was pointing 3, right? So what we will do, we will erase 3 from here. Okay, and here we will make it 4. Make it 4. So this means it will point to here. Okay, and this linkage will go off. This linkage will go off. So this is what my idea is to implement it. Okay, so let's go and do the coding. And we will be again using the same code because we don't want to create it again and again. So delete nth from end. And so in example I have explained, right, nth node what we want to, so what we will pass, self is by default nth we will pass, right? So first we will do check if less than equal to 0. If there is no node at all, then means it's pointing to -1. This means that they is pointing to the, means not even the 0th node. So that's what. So we'll return from here. That is, and now we will take a dummy node to implement this. I will explain you at the last where I will be using this dummy node. So this we will initialize to node 0, and this will point to what, start of the node. So this will be basically used in case of deleting the head node only. If we are deleting the head node, we need to take the we need to make the start the next node, right? Head dot next. So before deleting it, we should make it. So that's what we will be initializing now, and now everything will point to start. And we will make it dummy because anyway we are pointing it to, and dummy is pointing to the this only. dummy will point to the next, and we are initializing it. Okay, so using the dummy node makes it easier. You can use it without dummy, but then we need to initialize. You need to compare. If it's head, then you need to do lots of things. So better we will not do this. Now we will go till I told you, right? If I in the example I told, right? If what I told that if we are going to delete the second node, first will point to the second node only. So we will take the first till then there, and we should take a check also that if first is already none, then we should not do anything and we should break. Means it's an invalid end, right? Always I use braces, which is used in C and C++. That's why. If you guys need all this code in C or C++, please feel free to comment. I will be happy to explain that as well. As I'm more focusing here on Python, that's why I'm giving all the lectures in Python only. But feel free if you are comfortable with C++. If you want the solution in C++, then let's have it in C++. I can create a session for you guys. Okay, so now I told, right, once it will move to second in the example, then we need to check that while fast dot next, where the next pointer is. If it is not null, then we will move both the pointer till the end. So target requirement here is that move the fast till the end last node. Don't terminate it to with null, but just move it till the last node. That's why we are making it till there. Guys, hope you guys are understanding. Let me know in the comment section so that if a certain improvement needs to be done, we can make it. So that we can achieve the final goal, that you understand and answer it in your interview. Build a concept which will be used for your lifetime, right? And what are the other sessions you need, that also you let us know. So now what I will do, that slow.next. This means that we need to delete that we told have shown the example, right? Slow will now point to the third node in our example. Third node from the beginning and second node from the end. We had the 4 nodes. So now what we did here, that we have removed this right link, and we have moved. This was the slow. So slow this was the slow. This was fast. Slow next dot next. We are moving it here, right? So that's what we need to do it. We have done it here. So slow dot next is equal to slow dot next dot next. Now this next will have not this. This will have next was 3 and next of 3 is 4. So we'll make it 4. That's what we have done it. Right. So hope you are getting this. And now the dummy is coming into the picture. So suppose we are deleting the head only, right? So now self.head should point to where? Dummy.next. So as we have initiated with the dummy node, so always now dummy.next will pointing to the with this calculation, dummy.next will point to the head only. That's why we are we have done like this. Okay, let's have it here and delete from the let's delete the first, second, third prepend. Okay, whatever we'll see in the example, and then we will, as for now, we will comment this line. We'll comment this also, and now we'll ll dot delete nth from end, and let's make it 2. Okay, so anyway it will display, and then we will delete one second node, and then it is, so hope it will, you guys will understand. Let's run it. So now second, 8, 10, 20, 30, second from end. So second from end is 20. So see, it's got deleted, right? So this is the node we deleted. So hope you guys understood. In case of any question, feel free to ask the question in comment section. I will be more than happy to answer all those. Till then, thank you. Keep subscribing, keep notification, and keep, guys, sorry, at last note I want to make, please make a note, practice all this code, go see it, close the video, make it on your own. If you are facing some problem, again come back, learn, but don't copy it. Learn, build the concept. Okay then, till then, thank you, bye.